If you have ever driven past a big power plant, you may have noticed some giant, curvy towers reaching high into the sky, often surrounded by clouds of white vapor. These towers are hard to miss, standing tall above the rest of the industrial landscape, and they often spark curiosity in anyone who sees them for the first time. They look a bit like enormous chimneys, or even upside-down cones, with a narrow waist in the middle and a wide, flared top. Their hourglass shape is both striking and mysterious, making people wonder what purpose such a design could possibly serve. These are cooling towers, and they are among the most recognizable and iconic structures you'll find in any industrial setting. Whether you see just one or a whole cluster of them, their presence is unmistakable. Their unique, hourglass-like curves make them stand out from all other buildings, almost like giant sculptures designed by nature and science working together. No other structure in a power plant looks quite like them. People often find themselves asking, why are these towers shaped this way? Is it just for looks, or is there a deeper, more practical reason behind their special form? The answer isn't immediately obvious, and that only adds to their mystery. The truth is, every curve, every angle, and every detail of a cooling tower's design is carefully planned out with science and engineering in mind. Engineers and architects work together to create a structure that is both efficient and strong, able to withstand the forces of nature while performing its vital function. Cooling towers are not just part of the scenery or background. They play a crucial role in helping power plants run safely and efficiently, making sure that excess heat is removed from the system so that electricity can be generated without overheating the machinery. Without these towers, many power plants simply wouldn't be able to operate at all. They are essential for keeping the plant cool and preventing dangerous buildups of heat, which could lead to equipment failure or even accidents. So, why do cooling towers have that special curvy shape? The answer is a fascinating mix of physics, engineering, and a little bit of inspiration from nature itself. Over the next few minutes, we'll explore how their design helps them do their job, and why this mysterious shape is the key to their success. Cooling towers have one main job: to help remove heat from power plants. But how do they actually do this, and why is it so important? Let's take a closer look at the role cooling towers play in keeping our electricity flowing and our environment safe. Power plants create lots of heat when they make electricity. Whether it's a coal, gas, nuclear, or even some renewable plants, the process of generating power always produces excess heat as a byproduct. This heat comes from burning fuels, splitting atoms, or using other energy sources to spin turbines and generate electricity. No matter the method, the result is the same: a huge amount of unwanted heat that needs to go somewhere. But too much heat is bad for the machines and the environment. If the equipment gets too hot, it can break down or become less efficient. Plus, releasing hot water or steam directly into rivers or lakes can harm wildlife and disrupt local ecosystems. To keep things cool, power plants use water. Water is excellent at absorbing heat, making it the perfect tool for carrying away excess warmth from the plant's machinery. Water flows over the hot parts of the plant and absorbs the heat, acting like a sponge that soaks up unwanted energy. This keeps the equipment at safe operating temperatures. But now the water itself is hot and needs to cool down before it can be used again or released safely. If it's not cooled, it could damage the environment or waste valuable resources. This is where the cooling tower steps in. The cooling tower is designed to maximize the contact between water and air, allowing heat to escape into the atmosphere as harmless water vapor. The tower acts like a giant air conditioner for the power plant. As warm water trickles down inside the tower, air flows upward, carrying away the heat and turning some of the water into steam. It takes the hot water, cools it down, and returns it to the system. The cooled water can then be reused to absorb more heat, creating a continuous cycle that keeps the plant running efficiently. This process helps the plant run smoothly and saves water by letting it be reused again and again. Engineers carefully monitor the system to make sure everything stays balanced and efficient. So cooling towers are an important link in the chain, protecting equipment, saving water, and keeping the environment safer. Without them, modern power plants couldn't operate as safely or sustainably as they do today. Let's break down step by step how a cooling tower actually cools water in a power plant. Cooling towers are essential for keeping power plants running efficiently, and understanding their process helps us appreciate the engineering behind them. First, hot water that has absorbed heat from the power plant's machinery is pumped up through large pipes to the very top of the cooling tower. This water is often heated by steam turbines or other industrial processes, and it needs to be cooled before it can be reused. At the top, the hot water is sprayed out in thin streams or droplets over a wide area called the fill. The fill is made of special materials that help spread the water out, increasing its surface area and making it easier for the water to cool down. As the water trickles and falls through the fill, it spreads out even more, exposing as much of its surface as possible to the air moving through the tower. This maximizes the contact between water and air, which is crucial for efficient cooling. Powerful fans at the base of the tower, or sometimes just the natural upward movement of warm air, pull fresh air up through the structure. This airflow is what helps carry away the heat from the water. As the air moves upward, it mixes thoroughly with the falling water droplets. This mixing is where the real cooling happens, as the air absorbs heat from the water. Some of the water evaporates as it meets the moving air. This evaporation process removes heat from the remaining water, cooling it down significantly. This method is known as evaporative cooling, and it's the key principle behind how cooling towers work. The now cooled water collects in a large pool or reservoir at the bottom of the tower. Here, it's ready to be sent back into the power plant to absorb more heat and continue the cycle. The cooled water is pumped back through pipes into the power plant, where it will once again absorb heat from the machinery. This creates a continuous, efficient cycle that keeps the plant operating smoothly. Only a small portion of the water is lost as vapor during this process. That's the big white plume you see rising from the top of the cooling tower. It's mostly just water vapor, not smoke or pollution. This visible cloud is a sign that the cooling process is working as intended. Some cooling towers, especially the biggest ones, don't use fans at all. These are called natural draft cooling towers. They use the difference in temperature between the warm, moist air inside the tower and the cooler air outside to create airflow. Warm air is lighter than cool air. As hot, moist air rises up through the tower, it creates a natural draft, like a chimney. This rising air pulls in fresh, cool air from the bottom of the tower. The tall, open shape of the tower helps this process work better. The narrow middle makes the air move faster, and the wide bottom and top allow for easy entry and exit of air. Using natural draft saves energy because there are no fans or extra equipment. It's a clever way to use the laws of physics to do big jobs. Now let's talk about the hyperboloid shape, the famous hourglass curve of cooling towers. This shape is not just for style. It is called a hyperboloid of revolution, and it has some amazing properties. A hyperboloid is a kind of curve that gets narrow in the middle, or the waist, and wider at the top and bottom. This shape is really good at guiding air smoothly upward. The narrow middle speeds up the airflow, just like, squeezing a garden hose makes water spray faster. At the same time, the wide base allows lots of cool air to enter, while the wide top lets warm air escape easily. The whole shape helps air flow smoothly, with less resistance and more efficiency. The hourglass shape is a perfect balance between letting in enough air, speeding it up, and venting it out, all while using less building material than a straight wall. The curves of a cooling tower are not just about moving air. They also make the tower much stronger. A hyperboloid shape spreads out weight in a very stable way. The curves help the tower hold up its own weight and resist bending or breaking. This is important because cooling towers are huge. Some are over 200 meters tall. If they were built straight up and down like a box, they would need much thicker walls. The curved design means the walls can be thinner and still hold up the whole structure. The hourglass shape also helps the tower handle the force of gravity. The wide base gives a strong foundation, while the narrow middle takes less weight. It's a smart way to make a tall tower that is both light and tough. So the curve is not just good for airflow, it's also a brilliant way to make a strong, stable building. Cooling towers are often built in open spaces where they face strong winds. Their special shape helps them resist these winds. A straight wall would catch the wind like a sail, but the curved hourglass shape lets the wind flow around the tower. This means the wind puts less pressure on the tower, so there is less risk of damage. The curve also spreads any wind force evenly over the surface, rather than focusing it in one place. Engineers use computer models and wind tunnels to test these shapes. They have found that the hyperboloid design is one of the best at standing firm against storms and even hurricanes. Thanks to its smooth curves, a cooling tower can be both tall and safe, even in tough weather. Building a cooling tower is a big job. Engineers use reinforced concrete, which is strong and can be shaped easily. Concrete is poured into special molds that create the curved, hourglass form. Inside the concrete, steel bars and mesh are added for extra strength. This makes the tower like one big shell, with no need for inside supports. The shell is thin compared to the size, sometimes just a few centimeters thick. The building process is done carefully, layer by layer. As the concrete dries, workers move the molds up and pour the next layer. This method creates a single, strong, seamless structure. The end result is a giant, curved tower that is both beautiful and built to last for decades. Cooling towers are more than just industrial sculptures on the horizon. Their special shape is the result of careful science and smart engineering. Every curve is designed to move air, save energy, and keep the tower strong. The hyperboloid shape guides air upwards, cools water efficiently, and uses less material. It stands up to gravity, wind, and weather, all while looking unique. The choice of reinforced concrete and the smooth, shell-like construction keep these towers tough and durable. So next time you see a power plant's cooling towers, remember, their shape is not an accident. It's a perfect example of how science and engineering work together to solve big problems, and do it with style. From airflow to strength, every curve has a purpose. That's the power of science in action.